What's going on, Algebros? Welcome back to another video involving combining two rational expressions. Here we're going to start things out a little bit differently than the two videos that we had before. Namely, if you notice the denominators of each of these rational expressions, they each happen to be quadratic trinomials. And because they are, what we're going to want to do before trying to construct the LCM is factor each of these quadratic trinomials if possible. So let's take a look at the first rational expression's denominator. We have x squared minus 7x plus 6. That does indeed factor, and it factors as x minus 6 times quantity x minus 1. With the second rational expression, we have x over x squared minus 2x minus 24. There are factors of negative 24 that add up to negative 2, and those factors would be x minus 6 and x plus 4. So negative 6 times 4 gives us negative 24, and the two numbers add up to negative 2. So that's how we decide on the factors of the second rational expression's denominator. Now let's go ahead and talk about LCM. What we want to do for the LCM is come up with an expression that is divisible by both denominators. As you saw in the last video, that involves involves taking these factors and just kind of multiplying them out as part of the LCM. In this case, what I want to do is take a look at each individual factor of the denominators. For instance, in the first rational expression, we have x minus 6. We're going to need to include that as part of the LCM. We're also going to need to include the factor of x minus 1. So with the LCM as it is, the first rational expression's denominator would indeed divide that product. But if you look at the second rational expression's denominator, x minus 6 times x plus 4, looks like we need to add one more additional factor in here, and that would be the factor of x plus 4. No need to add in an extra factor of x minus 6. After all, we are looking for the least common multiple of each of the denominators. So basically, long story short, to form the LCM in this case, you take all of the different looking factors and just meld them together. So x minus 6 is different from x minus 1, is different from x plus 4, so we just go ahead and combine them via multiplication to form our LCM. Now with that said, we now need to get down to business and add these two rational expressions together. So we are going to need to adjust each of these so that each rational expression has the LCM involved in its denominator. So if you look at the first fraction, we have the two factors x minus 6 and x minus 1. We are missing the factor of x plus 4 from the LCM, so for that reason I'm going to multiply top and bottom of this fraction by x plus 4. And if you look at the second fraction, we are missing the factor of x minus 1 from the LCM, so for that reason we're going to multiply top and bottom by x minus 1. And now it's off to the races, simplification and combining and so on and so forth. First thing I'd like to do is distribute the x to clear parentheses here. We get x squared plus 4x. That's going to be all on top of the LCM. X plus 4, x minus 6, x minus 1. That rational expression is going to get added to, let's clear parentheses here, so x squared minus x, all on top of the LCM, which I'll write it in the same order as the first fraction, just for consistency. And there we have it. Since each of those rational expressions has the common denominator, we can go ahead and combine the numerators. It's via addition. And I'm mentioning that for major reason being is that we don't need to include parentheses around the second rational expression's numerator. That would only be the case where it's subtraction. So here, no need to worry about an extra set of parentheses. So in other words, here we have the combined version, well not fully yet, but here we have the sum of the numerators. And I'm just going to write that on top of one copy of the LCM. And then check to see if there's anything in the numerator that combines, i.e. like terms. And it looks like we do have some like terms. X squared plus x squared gives us 2x squared. 4x minus x gives us positive 3x. All over, you guessed it, the LCM, x plus 4, x minus 6, x minus 1. Last but not least, it looks like there's a GCF of x in the numerator, so we'll take that out. Left over is 2x plus 3. And that's all on top of, you guessed it, another copy of the LCM. Alright, so once everything is fully factored, you just want to check to see if any factors of the top cancel out any of them in the bottom, and obviously we don't have that in this case. So that means that we are finished with this example. Of course, if you have any questions about it, feel free to let me know. Otherwise, I appreciate you watching, and I will see you in the next one. Take care, my algebros.